Hello everyone, my name is Filippo Marcantoni and this is a review of the article Cobots in Industry 4.0, a roadmap for future practice studies on human-robot collaboration. This review is done for my human-robot interaction course at Worcester Polytechnic Institute. In the human-robot collaboration and human-robot interaction fields, particularly when it comes to cobots, research has focused on trying to identify the appropriate level of collaboration between human and non-human entities, and specifically on operators' experiences interacting with the systems. Research lacks in investigating social practice and workplace implications that could provide significant insights on collaborative work between human and non-human agents. The article outlines the main themes and gaps in the existing research on human-robot collaboration in Industry 4.0 by using the Assist Me project as an example case study. This article argues for more practice studies on cobots in Industry 4.0 that could enable robot-supported collaborative work and give us a better understanding on how robot-supported work actually affects the social technical environment at the individual, team, and organizational level. Human-robot collaboration in Industry 4.0 needs to be thought of as a complex socio-technical environment in which human and non-human entities are both agents that act in the same physical and social space. Cooperation and collaboration are different forms of interaction. While they both involve a common objective and close interaction, they differ in how much the work performed by the human and the robot depend on each other. In cooperation, humans and robots handle separate subtasks that contribute to a common goal. In contrast, collaboration involves both humans and robots working together on the same tasks, requiring ongoing coordination. There are fundamental differences in between automation, robots, and cobots, each pivotal in advancing industrial efficiency. We can define automation as the process of completing a task without the need of human intervention. Robots, instead, are programmable machines capable of carrying out complex tasks, often with a degree of freedom. Meanwhile, cobots are collaborative robots designed to work, interact, and collaborate with humans. The article outlines the key themes in the research areas of human-robot interaction, work and organizational psychology, and sociology of work. The safety and situation awareness area of study for cobots often involves focusing on safety in terms of usability and performance, and how to maintain safe operation, avoiding to put the human operator at risk. The programming and teaching cobots area of study investigates how to design end-user interfaces which allow for low-skilled workers to have an active role in programming and interacting with the robots. Particularly, the article argues that future studies should further examine which interaction modalities are intuitive and how the process of programming, teaching, and using cobots evolves for different users over time. Task dynamics research focuses on deciding which tasks should be allocated to the humans or robots to effectively and responsibly collaborate. The article pushes to explore the condition in which the operator may maintain control and responsibility and the impacts of the overall work outcomes. Trust of cobots can help strengthen interactions, collaboration, and even acceptance of the systems. Research focuses on whether the system is trustworthy with an appropriate level of trust and how errors and faulty robot behavior can impact trust. The article argues that trustworthiness should be understood as an inherent factor in human-robot interaction, with the need of more studies on trust violation. For skills, training, and workload involving cobots, it is believed that there will be a lower need for highly skilled workers. However, there will be a need for new training or literacies to work in such fields. Research focuses on upskilling the workforce to understand whether cobots reduce workloads or not. The article uses the project Assist Me as a case study to highlight and explain the gaps in the existing research on human-robot collaboration in Industry 4.0. The project's goal was to develop novel interaction paradigms for a cobot in two different applications: the assembly of an automotive combustion engine and the polishing of casting molds. The first application scenario involved assembling a combustion engine in an automotive factory, specifically the installation of a cylinder head cover. This process was performed manually by placing the cover onto the motor block with screws already pre-inserted. A cobot was then taught the required position to perform the automatic screw tightening. This collaboration between the human stuck in the cover and the cobot tightening the screws aimed to assist and lighten the workload for the human worker, as the teaching of the cobot only needed to be done once. The second application scenario involved positioning a workpiece and programming the cobot to polish the eroded surfaces. This approach aimed to greatly reduce manual workload, as traditional air pressure driven polishing is labor intensive, non-ergonomic, and harmful to health. Continuous casting molds are often custom made, and polishing is the most demanding step, requiring many hours. Therefore, teaching the cobot positions is a key part of this process. The Assist Me project revealed several research gaps that can be categorized as collaboration partners, collaboration settings, collaboration dynamics, control and responsibility, and job profiles and work design. Through the use of the Assist Me project as a case study, the article outlines the key themes in the research areas of human-robot interaction, work and organizational psychology, and sociology of work. In the Assist Me project, the focus was on the operator teaching the robot a task, followed by the collaboration for the task completion. Turned out that the collaboration worked well enough in the automotive scenario, meanwhile the polishing task was not performed accurately enough. Regarding the collaboration partners research gap, in the Assist Me project, the focus was on the operator teaching the robot a task, followed by the collaboration for the task completion. Turned out that the collaboration worked well enough in the automotive scenario, meanwhile the polishing task was not performed accurately enough. This led to some valuable insights about the effects of the collaboration. Firstly, operators felt good and proud that robots could not replace them yet. Secondly, even though the interaction between the robot and humans worked well, the collaboration was seen as ineffective because the robot did not polish well enough. And thirdly, the industry partner lost faith in the usefulness of cobots for their needs. As research has been focusing strictly on operator-robot relationship, these findings suggest that future studies cover the impacts of interactions in larger teams with multiple actors in the factory. This will help create better ways for people and robots to work together and challenge the idea that collaborative robots are always safe, flexible, and easy to use. Regarding the collaboration setting research gap, one study in the Assist Me project found that even a short-term implementation of a robot on the production line provided valuable insights. It showed that the robot's interaction could be improved as its work speed could be adjusted, and showed how the robot affected the work environment as operators were feeling less social with their co-workers and didn't want to work in the same area. Even though there are many examples of successful teamwork in human-robot collaboration research, these examples are rare in real-world factories. Research has not put much effort in investigating how cobots are actually used in manufacturing or evaluated the real-life application. Studying cobots in Industry 4.0 can be challenging because putting them directly on the production line might lower the overall productivity. But if we only examine cobots in isolated parts of the factory, we miss the understanding of their full impact on work. Regarding the collaborative dynamics research gap, in the Assist Me project, we saw that using a robot on a production line for a long time changed the work rhythm and social dynamic between human and robot. Research lacks in investigating how cobots will affect work over time in real-world settings, so long-term research can lead us to a better understanding of related impacts and how trust in cobot builds, is maintained, and fades over time in real workplaces. Most research is a short-term and lab-based, and we still need more studies on how different work contexts affect trust in cobots. The control and responsibility research gap refers to the main issue with automation and robotization, which involves the necessity for humans to set goals, be accountable for achieving them, and handle any negative outcomes. In the Assist Me project, there were significant challenges for achieving effective shared control between human and robots. Although interaction design improved over 3 stages, this often meant limiting the operator's role and the cobot's functions. In the final stage, operators performed well on specific tasks but lacked overall system understanding and control, leading to a dependence on the cobot. These dynamics raise ethical concerns about automation's impact on control and responsibility in work environments. The unpredictability of autonomous robots means that even well-designed interaction cannot anticipate all scenarios. Therefore, making robot behavior more understandable and enabling humans to recover from failures are essential steps. Additionally, research on social psychological effects of shared control in robot-supported work is limited. As cobots and other technologies alter human roles and tasks, they may reduce people's willingness to take responsibility, leading to a sense of lower influence over the work process. Finally, the last identified research gap is job profiles and work design, as research highlights a gap in understanding the skills and future job profiles needed for working with collaborative robots. While the Operator 4.0 concept suggests that cobots should support rather than replace human co-workers, there is limited exploration of how job roles and work organizations should evolve. The Assist Me project aimed to design intuitive interactions between cobots and operators to minimize training. However, it did not fully address broader impacts on hierarchies, decision-making, and traditional control. Operators were happy that robots could not yet match the human precision, which alleviated concern about job displacement. Future research should focus on holistic socio-technical approaches, including how cobots affect work organization, skill needed, and human involvement strategies. The authors proposed that future research on cobot in Industry 4.0 should use a computer-supported cooperative work, social practice lens, to better understand how cobots are applied and their impacts on the manufacturing environment. The research should focus on the experiences of different human stakeholders and the overall socio-technical work environment to improve human-cobot interactions and work conditions. The proposed research outline includes 3 levels. The individual level, which study how different roles interact with cobots to optimize task allocation and improve interaction design. On the team level, which investigate how cobots support teamwork, flexibility and adaptation, and how to design cobots to integrate well with team dynamics. And organizational level, which explore novel collaboration scenarios and organizational impacts, such as how cobots can be reprogrammed for specific contexts and how their implementation affects work design. Other identified important research themes include the interaction design, which should focus on creating intuitive, flexible interactions between humans and cobots. Use and adoption, which evaluate how trust, competencies, and social norms affect the acceptance and integration of cobots. And finally, structural impact, which assess how cobots influence job skills, team dynamics, and educational needs. This outline emphasizes a transdisciplinary approach involving all relevant stakeholders, as this is necessary to address the complexity of the phenomenon and achieve meaningful insights. The article concludes that while cobots offer promising benefits for small and medium-sized enterprises, their current applications are limited and have not significantly replaced human jobs yet. Future research should focus on integrating cobots into workflows more effectively, considering automation impacts cognitive workload, skill requirements, and work quality. Also, the use of cobots might make it harder for people to take responsibility and control. This shows the need for an interdisciplinary approach involving all stakeholders and social practice studies to better understand and improve the integration of cobots into work environments in the context of Industry 4.0. Please let me know if there are any questions. Thank you for your attention.